Big Data, Hadoop and R， 这是统计上面的资料呈现如何跟 Hadoop 结合的一个 session。我相信这个东西，对于我们 confuse 在一些大量资料里面吐出来的一些东西，它到底什么意义？这部分可以对我们有很大的帮助。让我们来欢迎一下 Laurence Liew。
Afternoon, everyone. I'll speak in English for the presentation because that's easier for me. But later in the questions, if you need to ask any questions in Mandarin, feel free to ask. I'll try my best to answer. I have a number of slides, and I'll go through within the next 40 minutes and talk a little bit about R and the use of R in not only Hadoop, but in general high-performance computing infrastructure. What I'll cover is big data. What is big data? I think there's a lot of talk about big data today. I'll just give my view of what big data is. Why you should consider R if you are doing your analysis. And we'll talk a little bit about high-performance analytics. There's actually two variants to this. This is HPC, as in embarrassingly parallel sort of computing, and the more tightly coupled, the MPI type of computing, right? So we support both. And then we'll talk about Hadoop, how R and Hadoop is working closely together, I'll show a very short video of R Hadoop in action. And if you want to see more, my partner's booth is outside, ID Miner. You can take a look at the live demo there. So, Revolution, it's a US company, and I'm their general manager for Asia Pac. So Taiwan is one of the countries that I'm responsible for. Today we have about 40 plus, about 50 employees already. Customers, we have about 150. The closest office to Taiwan is actually Singapore. So I'm based in Singapore. I have a development team in Singapore that is looking at putting R onto the cloud. So these are just a short list of some of our customers, mainly in finance and increasingly in telco and government. So R is today used in the enterprise by lots of government agencies, by banks in the region here and in the US. So I hope that in Taiwan, eventually we'll get more and more commercial customers. So just very quickly, R is a statistical programming language. Can I have a raise of hand who is familiar with R? Or have heard of R or use R? Don't be shy. It's okay. I mean, I'm sure a lot of you are from academia, right? So you should know R. Okay, just a handful. So it's an open source statistical programming language that has lots of algorithms for statistics and analytics, of course. And what we really add to it is that we bring in more performance, make it go faster, and we make it easier to use, and we have certain additional features to make it enterprise deployable. So that's very important. How do you move an open source project that is primarily used in academia to the enterprise? So we have done that, and now our enterprise customers are using that to deploy R models in the enterprise in a repeatable production quality manner. So these are some of the improvements that we have done. To make it go faster, we recompile it with Intel compilers and the Intel Max kernel library. So that gives you a significant speed up of anywhere from 5 to 10%. And we have tuned a number of algorithms for big data where we can run it in parallel in a cluster, and within the next 8 to 12 months on Hadoop transparently to the R programmer. So that if you are programming in R today, you make a function call, it can run on a laptop, it can run on a cluster, it can run on Hadoop, without you making a change in your source code. For those of you who come from a high-performance computing background, if you program in parallel with MPI, you know how difficult it is. We have removed that complexity from you as an R programmer. Your one single line of code can now run on multiple architectures. So just a quick step back, right? I mean, before cloud and Hadoop, my background is high-performance computing. I've been building HPC systems for many years. In fact, I was last in this place a couple of years ago where we were bidding for a big supercomputing project, and I represented Cray at that time and Dell to bid for the project. So I've been in HPC for many years. And we have seen how HPC has grown from Ethernet-based clusters to gigabit, and of course today InfiniBand and 10 gig E. So the same technology that is driving high-performance computing for the last decade is today the same technology that is driving Hadoop. Right? When you look at Hadoop, it's the same thing. It is servers, it is interconnect, it is RAM and hard disk, and so on. So nothing has really changed. The only thing that has changed is just the management of the data. That, our HPC world, we did not do as well. We did not have a sexy name or a nice picture like Hadoop. But we have always been doing big data. What HPC guys have been doing, we manually split the data across all the nodes. Or we use a parallel virtual file system that automatically splits the data across the nodes. We have been doing it the hard way, right? Hadoop just makes it a little bit easier. So when you talk about big data and analytics, analytics is nothing new. It has always been around and was previously known as statistics, right? But the interest really is today because of the low cost of commodity hardware. You can do really big data analytics, and of course, people are talking about analyzing social media, Twitter, Facebook, and so on, and it has gotten a lot of interest, okay? So, but again, you have to remember, right, what we are talking about today is technology that has been around for many years. The only difference really is economics. You could do regression, the same regression 10 or 15 years ago, just that it was very expensive if you want to do it on all your data. But today, you can do it very cheap. And of course, your CPU has gotten faster, right? So what is big data? When people talk about big data, you have to think of three things, right? It's not just the size of the data. You have to think of the velocity. So I always like to use Twitter as an example. Each Twitter stream is 140 characters. So it's very small. But it is considered big data if you are going to mine Twitter. If you're going to get all the Twitter feeds coming in real time, the data becomes very big. So you have to consider not only the size of the data at rest, but the size of the data when it's moving. And the variety meaning unstructured, semi-structured data. So typically when people talk about data, it is volume, velocity, and variety. Okay, so it's not just about size, okay? So why are people very interested in big data analytics today? Number one is, again, because it was very expensive 15 years ago, you could not analyze all your data sets at one go. The computing power was just not there, and even if it was there, it was very expensive to do so. But today, with technology like R and Hadoop, you could do it very cheaply. And therefore, from a statistician point of view, you do not need to do sampling anymore. You can analyze all your data at one go, okay? The other thing that I want to highlight about big data is data is today treated as a perishable goods. It's like food sitting on the shelf, right? You need to act on it immediately. I still hear of companies that collect a lot of data, they don't do much with it. They are just storing it because the management requires it to be stored, or regulation requires it to be stored, or they are just storing just in case my manager asks me about something. So it's very sad, because if you do not act on your data when you get it at that point in time, after a few weeks or a few days or even a few hours, depending on which industry you are in, it has less value or no value at all, right? So you need to act on data that you collect, but when you act, or when the insights that you generate from the analytics, there's also another important thing. The insights that you generate from analytics needs to be actionable. If the data that you get cannot be acted on, it's just an academic exercise. Okay, so that's important for the budding data scientists out there. So I mentioned this a few times, so I thought this is an important chart. Economics. The reason why today we are able to do big data is economics. The cost of hard storage has come down from a couple of million dollars to about a few $100s today, 1 terabyte, right? That's $300, not 30. The cost of CPU has dropped tremendously, right? And so has the cost of bandwidth in the form of 10 meg to 100 to gigabit Ethernet and so on. So all these costs has dropped tremendously over the last decade or two. And this has allowed us to now process huge amount of data at reasonable cost, right? The underlying algorithms has not really changed at all. It is just economics that has now enabled us to do big data. So these are the few things that I want to share in terms of what are the big data stacks that are very popular. At the lowest level, of course, you're looking at the how you're going to store that data. You have the open source database like MySQL, Postgres, and of course you have Hadoop. You have the commercial versions of MySQL like InfoBright or Greenplum. EMC from Greenplum basically took Postgres and modified that to make it into their data warehouse. So that's the data storage layer. We'll talk a little bit more about Hadoop later on. You move up, the next layer is the analytics, right? You have, I think I heard Mahal, founder, spoke earlier. You have MATLAB, you have Scientific Python, and of course you have R. R has been around for the last 18 years, so it is not something that's new. It's been around for a long time. And when R was designed, there wasn't big data, there wasn't Hadoop, right? It was designed for a desktop environment. So we have basically taken it one level up to now run on big data, on clusters and on Hadoop. Now, a lot of you here, I guess some of them are very young, probably still in school or doing your final year research and so on. You may join a commercial company, but the next place where money is to be made is really in analytics services. We are seeing a lot of startup companies providing very specialized analytics services to customers, partnering with us, for example, right, to use technology like R and Hadoop to provide insights to the telcos, to the banks, right? And a lot of these startups come with very deep technical expertise because of the PhD research that they have done in school. Okay, so that's really if you are thinking of doing a startup, either you create a product or you create your services, right? And to recreate R will probably cost about $150 million, right? We have done the study. It will take that much to do a new statistical programming language. So it's a lot easier to grab a few friends together and do services for companies and start from there. So R is a data analysis software. Most of the algorithms that you can think of or you want to use is already there. This is a very simple, short snippet of an R code to basically generate a word cloud. Mr. Brown is a very popular blogger in Singapore, and not only the government, but the opposition also watch what he says, and what he says, will sway sentiments and so on. So this was just a very simple snapshot of how we will do a simple word cloud or sentiment analysis. And there's a package called Twitter R that you can use. You basically do a search on the hashtag Mr. Brown. We are limited by Twitter's API, 1,500 tweets. We apply the functions, we apply the corpus, and then we map it, right? TM is another package. And then basically in the end, you can do whatever you want, you can sort and so on, and you can, with one line, you can do a simple word cloud. With 3 or 4 lines, you can do a more colorful word cloud. So R really is a language meant for analyzing data. I received an email after I gave a talk at the local university 2 weeks ago, and the email was very interesting. It came from one of the master students, and he basically said that, you know, initially they started learning SAS in the university, and then they started learning R, and he continued to experiment with R. And what he said in the end was, using the other tools, it was just learning how to push buttons. But using R, not only did he get the results he needed, but the process of getting the results made him understand his data a lot more. So it is the process of getting your data and getting your results, right? It's the process of getting the results that made him understand his data a lot more, and that is where R is powerful. It is not a tool that gives you a few buttons to push and a black box and get your results. It gives you the ability to do a journey with your data and understand your data better so that your insights are a lot more powerful. So R is increasing in popularity, definitely. I'll go a little bit faster. To analyze data, you need to have very good graphics. So R has very extensive packages for graphics visualization. A lot of fancy charts and graphics that you see in published papers today are all done in R. You go to New York Times, it has a very big data science team. A lot of the visualization and graphics you see on New York Times are all done in R, or at least generated in R first. So all the statistical model you can think of is there. I have a neural net AI background, so all the neural nets and fuzzy logic that I like is all there, okay? Lots of cutting-edge analytics, specific domains like genomics and portfolio optimizations. There are big packages that are already available. So if you are doing life science, the first thing to check out is the bioconductor. So even before you write your own R script, right, check out what other people have done, and you can probably reuse a lot of them. So let's look at how do you analyze big data with R. And what Revolution have done is that R has a limitation in that it cannot process. How it works is that it needs to load everything, all the data you want to analyze into memory before it can start processing. It will work when your data sets are small, but today's data sets are getting bigger and bigger. RAM is cheap, yes, today you can get laptop that can go up to 32 gig of RAM. But even then, there are customers whose data sets are much bigger than that. And R will flop, open source R will fail, right? It cannot do that. And what our engineers or scientists have done is we have made it possible by creating XDF, innovative file format, and also making the algorithms big data aware. So instead of loading, let's say, 1 million observations into memory, you load 100,000 at one time, update the algorithms, load the next 100,000, and so on and so forth. By doing that, it's actually quite fast, right? The penalty of splitting up your data sets that way is not that high. But what has happened is that by breaking up and making the algorithm into chunkify the data and algorithms, we have made R high, or rather our sets of algorithms highly parallelizable. So that same technology today allows you to run that same R code on a laptop and scaling up onto a cluster without any change in code. And that same technology today is being applied to do the same thing. Because it's all about splitting data. right? So one of the questions we get is that I don't have big hardware. So how do you do big data analysis on your desktop? And what's actually surprising when I first got into analytics and Revolution was that today you can actually process 1 billion records on a reasonably modern desktop. 1 billion records, okay, mind you, that's huge, right? And it is possible today because Revolution has created versions, right, that overcomes that. And it's pretty sad because of the last line here, right? I met a friend who paid a hardware vendor $500,000 to buy 2 servers, each with 1 terabyte of RAM, just because his data set was that big and he needed to run R. I told him, you know, you could have saved yourself $400,000 if you just come and talk to me. Okay? So imagine, right? You can save $400,000 by using Revolution R. So this is a big logistic model. This was done, this is a logistic regression model, 50 parameters, which is quite large, right? And it ran in about 6 minutes. There was about 100 million rows or observations, right? 50 parameters. So you'll see that the function call is really just RX logic. In open source, R is called logics. In our version, it's called RX, right? Now, what if this is not fast enough? Now, this, again, 100 million done in 6 minutes. For some people, this is good enough on a desktop. This is a reasonable, a modern-day laptop. So I need to be ready for tomorrow's data, scaling to a cluster, right? I'm sure in this room there are several people that have the same background as me in high-performance computing. So I reran the same code on a cluster, a $5,000 cluster, 5 nodes, and I did it in 42 seconds, from 6 minutes to 42 seconds. No change in code. The only thing that we needed to add in was this line called compute context. Basically, to tell the code where to run your R script. So we can run on a Windows and so on. This chart, I'd just like to flash. This is a competitor. We processed 1 billion rows of data in about half the time, 44 seconds. We did it on a $5,000 hardware, 5-node cluster, the same one that I showed you earlier. For them to do it in 80 seconds, they need to use a 32-node cluster, okay, with 1.6 terabyte of RAM. Right? So this is really about high-performance computing, about the ability to break data up into chunks that you can process in parallel. These guys can't do it. And what's nice is that the next column, which my team is in the midst of preparing, this is, okay, just for your information, the hardware here costs $2.5 million. This one here costs $5,000, the 5-node cluster. The next column, which I hope to have the results in the next month or 2, the hardware cost will be $15 or $25. Why? Because you can do the same thing on a cloud. Okay? So this is about splitting the data running on a cluster. So we can do that today. We run on multiple platforms, from HPC clusters on Windows to Linux, Hadoop, and in-database analytics. This is just another chart to show you the scalability and so on. So like I mentioned, there's 2 types of analytics that our customers or users are doing today. The HPC type, what we call embarrassingly parallel, the Monte Carlo simulation, that's a very good typical example. So we can handle that. And the more tightly coupled, the MPI type, where the algorithms needs to be specifically built for those type of computing. So those are the linear regression, logistic regression, and so on. So this is the set of big data algorithms that we have. Now, in terms of Hadoop, parts of this will become Hadoop aware also in the next couple of months. So we are working on that. So let's move on to R and Hadoop, which is really what a lot of people are interested in today. I won't talk about Hadoop because you have heard enough of it this morning. But why did we start a project? So the R Hadoop project is an open source project that Revolution started. And today you can write Hadoop MapReduce with Java, Pig, or Python. But a lot of analysts is familiar with R, and they want to use the R programming language on Hadoop, and that's what we are trying to make it possible. So we have R Hadoop project. There are 3 packages: R HDFS, R HBase, and RMR. Okay, so HDFS, of course, allows you to write R code to talk directly to the Hadoop file system. And the RHBase allows you to talk directly to HBase. Okay, I'll show you some of the code later. And RMR allows you to write your MapReduce code in R and execute on a Hadoop cluster. So today you can actually run R directly in a Hadoop cluster. Okay, we are one of the few analytics software that can do that. What are people using R for in Hadoop? Okay, one of it is what we call data distillation, right? Really, where you are using R to process or pre-process your data. And of course, you can also run R in Hadoop for your statistical analysis. So there are many ways that people are running R, where they are only using it to process data. They are not doing any analytics on it, and there are reasons for that. One of the reasons why people only use R to process data in terms of sorting, merging, and so on, and not doing the analytics is because the analytics, if you were to rewrite it and run into MapReduce to run on Hadoop, may take too long. It could take you 6 to 8 months of work with a team of analysis and software programmers. But if that particular algorithm that you want to use is already available that can run on a normal server or on a HPC cluster, you can build a cluster in half a day today and have your program running by end of the day. Right? You do not need to wait 6 months, 8 months, take on the risk of developing that algorithm to convert it to MapReduce. So that's actually a lot of how our customers are running R and Hadoop. They are using Hadoop to store and pre-process a lot of data, but the analytics itself is actually the data is actually pulled out to a separate R server or cluster to do the processing. So that's what we call the next two. So this is a diagram of someone that's running R in Hadoop itself, right? So, but this is not the common one. This is what everybody in Hadoop and R would like. But it is, in reality, in practical terms, this is very few, okay? What is more common is this model, where people actually have Hadoop, and they actually have a separate R server or cluster that does the analytics, because the analytics software has already been written to run and scale on a cluster. So to rewrite that would take many months. So RHDFS, so we basically allows you to manipulate HDFS directly from R. These are just some of the function calls. I have a short demo that will show you some of this later. So you can basically do all your copy, move, and so on, create directory, and so on. RHBase, where you allow you to talk directly to the HBase tables. And these are the functions. Now, R Hadoop is an open source project. I had a few requests where someone said, can we execute R directly in HBase? That means doing in-database analytics. Right? So today we have that for NetTeaser. So we had a few partners that came to us and said, can you do the same? What you did for IBM NetTeaser, where the analytics in the database. Can we do it the same for HBase in Hadoop? So our Hadoop is an open source project. If anyone here would like to contribute that, more than welcome. So RMR really is designed to be a very simple, elegant way to write MapReduce programs for the R programmers. So you basically have the MapReduce, just one function. You put in your input, output, and then your map and reduce. Right? So this is a very simple example where you basically do a square root. Right? This is a normal R script, the first 2 lines. The next 3 lines is how you do it in MapReduce. Binomial. Again, you see in R, in a standard R, it's very straightforward, very easy to understand. But once you change it to MapReduce, you need to think like a MapReduce programmer. So that's another hurdle that some of our R users are trying to get around. Right? Word count in R. So this is logistic regression, but a very simple logistic regression. That's why it could be done in a page. But you see that it's actually quite complex, right? So you need to understand the statistics very well before you can reprogram it into a MapReduce function. So it can be done, right? But how powerful and how quickly can it be done? So this, so like I said, my team is looking at putting R onto the cloud, and we have been doing a lot of research, and definitely will be open to any collaborators from Taiwan, from NCHC and Sneaker and so on. How do you run R on the cloud effectively? So these are few interesting statements that I got from the internet, and what's very interesting to me is that the Yarn project, the Hadoop 2.0, they are actually replicating or re-implementing what the HPC folks have done the last 10 or 15 years, right? Trying to write a scheduler that understands MPI and so on. And they are actually not doing a very good job, unfortunately. So you'll see that, let's say, a word count program that processed 1,000 files took about 6 minutes using Yarn. But if you were to use standard MPI or OpenMPI MR+, that is the Hadoop on demand, right? You only took 11 seconds. Okay? And just running a standard Hello MPI, non-MPI Hello program on an 8-node system took 20 seconds to run on Hadoop, right? And about 25 milliseconds on a cluster that is not running Hadoop. So Hadoop has its overheads. What I want to show, I hope you can get away from this slide is that Hadoop is good for a lot of things, but it is not meant for everything. Okay? This slide will tell you that there are certain tasks that is better to be done on a traditional HPC cluster. Okay? So use the right tool for the right job. Right? You have to understand whether your data sets, your problem domain can be solved by Hadoop. If you look at, for example, Caldera, right, one of our partners, you go to their website, you can download Caldera and use it for free. Up to 50 nodes. Beyond 50 nodes, right, you have to pay an enterprise license. It tells you something. It tells you that if your Hadoop cluster is less than 50 nodes, it is not even considered production. And you're probably not going to see, I won't say you won't see value, but you're probably not going to see much performance out of a small Hadoop cluster. So if you're thinking of building a Hadoop cluster, you must be ready to put in place, right, I would say, something beyond 50 nodes, 50, 100, 1,000 nodes. Then you are talking about, yes, it's a Hadoop scale problem. If your data sets if you can fit into a 10-node Hadoop cluster, you can probably do it faster on a single server or a 2 or 3-node HPC cluster. Okay? So this is again a very important slide in the sense that, like I say, Hadoop is not the one and only technology that the enterprise use today. Today we are talking to a lot of commercial companies. They use different technologies for certain different things. So we have customers that users, they still keep their traditional data warehouse. They front end it with a Hadoop cluster for storage, pre-processing. The data scientists will either have powerful workstations or clusters for analytics. They will still keep this. This will still be around, right? So what we are seeing today is customers having these three scenarios: powerful workstation and clusters for analytics, central data warehouse, Hadoop for pre-processing. This one will stay, and one of the reasons is, if you spend 10 or 20 million to set up a big data warehouse, I bet you that you as the IT analyst or statistician, you go to your IT and say, I want to run my analytics jobs on your data warehouse. They will tell you, go and fly kite. Because they will not allow an unknown workload to spin up on their central data warehouse and slow down the whole organization. They will prefer you to extract out a certain set of data and run in your own small little cluster or data mart. So that is nothing to do with technology. That has to do with just the realities of enterprise deployment. So that's why a lot of customers, a lot of data scientists end up having their own little clusters. Okay. So let me see whether I can find the video. I'll just play a short video. This one? Okay. So this is a short video that we did more for discussions and demos. And you can actually download R Hadoop from GitHub. Okay, it's already available there. And I will skip the first few parts because it's really about Hadoop. But this part is where, I apologize that it's not very clear, but this is actually a set of R scripts that is running, or R Hadoop scripts, right, that is being executed and run. And you see that you can actually create files and so on and so forth. This video is a bit big. It's like 60 meg. But anyone who's interested, you can come and look for me later outside, and I can show you or pass you the video. So this basically shows you that R HDFS, R HBase, and RMR is working, and people are actually using it today in their R Hadoop projects. So like I mentioned, R Hadoop is an open source project. We welcome collaborators. Taiwan actually has quite a number of very bright people. Like I mentioned, I come from the HPC background, and one of the big projects that we follow is the Clonezilla project that came out from, I think, if I'm not mistaken, in Taiwan. That's a nice way to do provisioning for Linux clusters. Okay, so I'll leave this video running. Are there any questions? You can ask in Mandarin. I'll try to answer.
Hello, sir. I have a couple of questions for you.
Yes.
I have been using R for many years, and I also a senior user of SAS for more than 20 years. And we know SAS is very expensive to use. And I try to move to R, and I know R has a good integration interface with Hadoop and so on and so forth. But to me, so far, I cannot see any reason for me to move from SAS to R in terms of analyze big data. For example, my data I used to analyze consist of tens of trillion of records. And I know therefore I would like to say R is better than SAS and so on. So and in this seminar you mentioned something like this. So could you give us more good example to justify, to tell us why R is better than SAS, for example?
Okay. So the question is, why is R, or why am I with Revolution and not with SAS? Okay. One, of course, is cost, right? R is based on open source. We Revolution as a company, we built on top of that. So the cost to customers are much, much lower. Cost is one. The other one is, of course, in R, you have all the statistics algorithms that you possibly need. The latest and greatest algorithms comes out in R first, before SPSS or SAS. So I met a Department of Statistics, and they said the reason why they're using R is the latest and greatest statistical papers that are published, the algorithms in there, is all in R. It's easier for them to just download the code and run and look at the new results. And comparing to SAS, right, the slide I showed earlier, where $2.5 million hardware to process 1 billion of rows of data, compared to Revolution R, where you can do the same big data with $5,000 worth of hardware. That one slide alone, when we showed that slide at a series of conference a couple of weeks back, generated for me more than 10 leads in various government agencies in Singapore. Everybody was very curious, how were we able to do it? Now, the reasoning is very simple. Both SAS and SPSS is a 40-year-old legacy technology, right? For them to change, to match our capabilities will require them to spend an order of $100 to $250 million to rewrite everything. They're not going to do that. Or at least they are trying, but they're not trying hard enough. In R, with the RevoScale R with XDF, we have made it highly parallelizable. And we can handle that big data problem that you have. So if you are probably using open source R and you hit the memory limitation. But I'm willing, anyone who wants a evaluation copy, just come to me. If you hold an EDU account, better still, just register on the website, it's free. You can easily overcome that memory limitations of open source R, right? So open source R technically is very good. The only drawback is really the inability to handle data more than the available memory on your machine. So our version allows you to overcome that. And the other thing why people are moving from SAS to R is that a lot of you here are studying R in the university. When you go out to work, you are telling your manager, hey, I don't want to learn SAS, I already know R, can I just use R, right? And that is happening not only in US, it's also happening here in Asia. A lot of customers that we talk to is saying that when I talk to the hiring manager, when I hire the fresh grads from the universities, they already come with R. For me to send them for training on SPSS or SAS, it does not make sense. They come with R, we just do all the new projects with R. So typically what's happening now is people will start new projects with R, and then as the older SAS projects become legacy, they will redo those in R. So remember, if you hold an EDU email account, you can register and try out Revolution R for free. Right? It's really our way to contribute back to the community. Right? You get all the RevoScale R, the big data capabilities. So I have customers that had a 4 gig laptop, right, that couldn't solve the problem, downloaded our version, and he's now very happy he could work on his big data problems. So you don't need to buy a lot of hardware. That's what I'm saying. You do not need very big, powerful hardware to do very big data analytics today, right? It's just smarter software, right? Okay. So I'll still be outside. If you are too shy to ask a question, just kind of look for me. 我可以讲华语，可是我华语不是说很好，所以 如果要我在台上讲的话，可能40分钟不够。
好，如果没有问题的话，我们谢谢 Laurence。
好，谢谢。